Well, hey there guys, it's Dr. Franklin and I'm back again with another video tutorial. This one will focus on how you can take a single score, transpose it into a z-score so that you can determine the proportion of scores that fall above it as well as the proportion of scores that fall below it. In addition to being able to do those two things, we're also going to transform single scores into z-scores so that we can make a determination as to the proportion of scores that falls within a range of scores. Now, in order for us to do that, I have this example that we're going to start reading through and we'll calculate together so that you can have a model of how you can do it on your own. This example reads as the following. A report in 2010 indicates that Americans between the ages of 8 and 18 spend an average of 7.5 hours per day using some sort of electronic device such as smartphones, computers, or tablets. Now, I know many of you guys out there are going, wow, this is a gross underestimation of how many hours people actually spend on devices. I got you, and in some regards, I'm with you. Nevertheless, this is the numeric and particularly the parameters that are given to us for this particular example. So take off your philosophical cap for just a second. Let's go with the numerics that are given to us. Assume that the distribution of times is normal with a standard deviation of 2.5 hours. That 2.5 hours means that the individuals in the population on average are about 2.5 hours away from the population mean of 7.5. And the problem is asking us to find the following values. First bullet, what's the probability of selecting an individual who uses devices more than 9 hours a day? So when you are given word problems like this, first thing that you need to do is identify the relevant numerics that's going to help you calculate your z-score and ultimately lead you to obtain your final answer related to proportion. Here we know that the population mean is 7.5 hours as circled here. The population standard deviation is 2.5 hours as I will circle. And we have a raw score given to us of 9 hours. Okay, now let's go ahead and write out the formula for the z, which is x minus mu over lowercase Greek symbol that represents population standard deviation, and the denominator. Here we have a simple deviation, and down here we have an indication of average dispersion. So from there, we can plug our relevant numerics into the z-score formula so that ultimately we can obtain a z for 9, be able to apply to the normal curve, and obtain proportion information based on what is being asked of us. So we have 9 minus 7.5 over 2.5. When we do the numerator out, we end up with 1.5. This is over 2.5. And 1.5 divided by 2.5 yields us a positive 0.60. Now this is the z-score that we will take to our unit normal table to ultimately find a proportion of individuals who use devices more than 9 hours a day. Now, many of you guys may be asking yourselves, how do I figure out if I go with the body or the tail? I'm so glad that you asked that in your mind, and I'm so glad that I have telekinetic ability and that I could read your thoughts and I can manipulate your thoughts and I could, let me stop. Let me just give you the answer. All right, these are the two pieces of information that you need to keep in mind when you're trying to decide if you go with the body or the tail when you go to your unit normal table. One, I want you to consider the direction requested. The direction requested. What do I mean by that? What I mean is, what exactly is the problem asking for? We know that it's asking for a probability, but more specifically, what probability are they asking for? If we analyze this question a bit further, we'll find that they are indeed looking for more than 9 hours or greater than. Okay. Now there's some important things that you need to keep in mind in regard to the unit normal table and the normal curve at large. Greater than always means you will select the proportion to the right, and less than always means that you will go with a proportion to the left. Okay, so as we go from left to right, the standard deviation units are increasing. So down here it's like -3, -2, -1, then you have 0, then you have +1, +2, and +3. So it stands to reason that if a question is asking us for a greater than proportion, then it's likely the case that that proportion that we will select will be to the right. Okay, if they're asking us for less than, then it's reasonable to suspect that we will have to go with a proportion that is going this way, to the left. Okay, so you need that information to determine if you will go with your body or tail once you get to your unit normal table. You also need to take into consideration the signage of your calculated z-score. Okay, take into consideration the signage of your calculated z-score. Now, to emphasize my point in regards to this information, let me pull up the unit normal table. So, the signage of the z-score is important because the sign of the z-score will dictate where your body falls and where your tail falls. Let's take a look at this graph here. So in this graph, we have a positive z indicated, and notice how the line that is slicing the distribution into halves is on the right side. Now z-scores are designed to do that, and when they do that, they create two different halves, and the larger half is always the body and the smaller half is always the tail. Now notice with this negative z-score how it's falling on the left side, and based on how it's dividing up that distribution, the body is to your right and the tail is to your left. So going back to the problem, since they're asking us for more than, and we know that greater than is always to the right, we will take the information they're asking us, more than, and couple that with the actual signage of the z-score that we calculated to make a decision as to whether or not we go with the body or the tail. Now in this particular instance they're asking us for more than, so we know that we're going to the right. We have a positive z-score of 0.60, so going back to our unit normal table, we will select this particular graph, and since we know that we're going to the right because they're asking us for greater than, in this particular instance we know that with the z-score that we look up, we're going to go with the tail. Okay, if we ended up with a negative 0.60, then we would not go with the tail. We would have to slide over and come to this particular graph, and we would have to go with the body, because remember, greater than is always to the right. So since we're here on our unit normal table, let's go ahead and look up the proportion associated with positive 0.60. So this is positive 0.60, and since it is a positive z-score, we know that we're going with the tail, so the correct proportion would be 0.2743. 0.2743. So that would be our final answer for the first bulleted question. Now, let's quickly move on to the second question. Second question says the following: what proportion of 8 to 18-year-old Americans spend between 8 and 12 hours per day using electronic devices? In symbols, this would be probability of a score greater than 8 but less than 12. Okay, we know that because X means raw score. Based on the direction here, we know that X would be greater than 8. And based on the direction here, we know that X would be less than 12. So they're asking for the proportion of scores that would fall between a raw score of 8 and 12. So what we need to do is calculate Z's for this. So we got Z, then we have 8 minus 7.5 over 2.5. Then we have 12 minus 7.5 over 2.5. When we do that out, we end up with 0.5 in the numerator, 2.5 in the denominator. End up with 4.5 in the numerator here, 2.5 in the denominator, and then 0.5 divided by 2.5 gives us positive 0.20. And then here we get a positive 1.80. Now, let me just do a quick visual aid for a second. They are asking us for z-scores that fall within this slither right here. Okay, they're asking us for a range of z-scores, and they are all on the right side of the distribution. So, a rule of thumb to follow with trying to find the proportion associated with the range, especially when you have two z-scores that are both positive, is that if you have two positive z-scores, subtract the tail of the highest z-score from the tail of the lowest z-score. Why am I asking you to do that? Well, if you take the tail of the highest z-score, which is right here, and you subtract that slither from the tail of the lowest z-score, which is right there in squiggly line, then ultimately, if you take this away from this, then you're going to end up with that piece right there. Okay? So when we go to our unit normal table, let's look up a tail proportion for positive 0.20 as well as a tail proportion for positive 1.80. So let's do that now. Right, so we're at our unit normal table and we are looking for 0.20, and specifically we are looking for the tail, and our tail can be found right there. So we have 0.4207. Now we need to look up the tail proportion for 1.80. And the tail proportion for 1.80 would be 0.0359. Now, remember that we just want a proportion of scores that is associated with being between positive 0.20 and 1.80. So we want a proportion of scores there. Okay, what we've just determined is that 0.20 and beyond is 0.4207, and 1.80 and beyond is 0.0359. So what we can do is take 0.4207 and subtract from it 0.0359 so that we can obtain the proportion that we truly need, which is 0.3848, which is our final answer. Okay. So that is how you can find ranges, and so that is how you can find proportions that are associated with ranges of scores when both of your z-scores are positive. When both of the z-scores are negative, you can go the route of subtracting the tail of the lowest z-score from the tail of the highest z-score. So in other words, let's say that we ended up with a negative 0.20 and a negative 1.80. Well, we could get the tail for the negative 0.20 going this way and make sure we write down what that proportion is, get the tail associated with the negative 1.80 and write down that proportion, and then subtract this smaller piece from this piece so that we can ultimately be left with what we need here. Okay. And then finally, if you have, let's say you had, z-scores that flanked the mean. In other words, you had a positive z-score, maybe +1, and you had a negative z-score, maybe a negative 1.0. And you were tasked with finding a proportion here. What you could do is utilize the D column. And the D column represents the proportion of scores between the mean and Z. So you could find the proportion of scores between 1 and the mean, and then you could find a proportion of scores between 1 and the mean again, and then what you would simply have to do is add up both of those proportions after you listed them down so that you can have the percentage of scores associated with that particular range. So I hope that this was helpful. Please feel free to leave comments below, and I look forward to creating more content for you soon. Take care.